Alright, so we're looking at a review of chapter, or an overview, not a review, but an overview of chapter 6, starting here in lesson 1, and we've graphed all these points, and we found where they were on the number line. We're not going to erase that. And then we have reviewed solving equations where we just had to get x by itself, and equations are no different, or inequalities are no different from equations. We still do the same thing. We're still trying to get x by itself. We talked about the trichotomy property, how we have 3 ways to compare numbers: greater than, less than, or equal to. The relationship between any 2 numbers can't be anything except those 3. We've talked about how the mouth is open toward the bigger number, that this is a greater than symbol, that's a less than symbol. When we graph on number lines in a few minutes, we'll use a hole for those. If they have or equal to, we'll use a colored in circle for those. And then here's what we need to concentrate on again. At most means less than or equal to. At least means greater than or equal to. Hopefully we have that written down also. So at most is less than or equal to. At least is greater than or equal to. Now when we start spending money, we spend X on dessert. We spend $3.10 on our hamburger and drink. And what we spend had better be less than or equal to, change that, less than or equal to $3.10, because you can't spend more than you have. And this is all I have. Now we're going to solve, this is supposed to be, this is supposed to be $2.15. So this is the hamburger and the drink. I'm trying to figure out how much to spend on dessert, that's X. And then we have $3.10. And what I spend had better be less than or equal to $3.10. So still solve for X the same way by subtracting $2.15. But X is less than or equal to 95 cents. So I can't spend more than 95 because that's all I had left.
I thought it was $1.05.
95 cents. Alright, so when you do this one, this is the dessert, this is the cheeseburger, and the amount you spend had better be less than or equal to $3.75.
So
okay, less than or equal to.
How did you calculate it was less than or equal to?
Because what I spend has got to be less than what I have. I can't spend more than what I've got. I could be equal to what I have. It could be less than what I have, but it can't be more than what I have.
So our equal sign was wrong? We got to put the equals on the other way? Is that what you're saying?
No, this is less than instead of greater than.
Okay.
Alright, so we're going to subtract $2.50. Now, here's what's so weird when you start chapter 6 as compared to chapter 3, because we get used to just doing that. And we don't think about it. You've been writing them for several weeks doing equations, and you've probably never given it any thought at all about writing an equal sign. But we're now doing inequality. So whatever symbol is here, remember to bring it down. Don't do an equal sign there. And how much money do we have left? $1.25. So dessert's got to be less than or equal to $1.25. We definitely can't afford that big thing of ice cream there, right? Alright, these are the properties of inequality. The point of this, just looking at the colors and, less than stays less than, greater than stays greater than when I add. Less than stays less than, greater than stays greater than when I subtract. So here's the point. I do not flip the inequality symbol. When do I flip the inequality symbol?
When you're multiplying negative numbers.
Right, when I multiply both sides by a negative or I divide. And I'm not talking about multiplication division in these properties. When I add and subtract, I do not flip a symbol. That's all these properties are saying. And remember, I told you that everything we do in math has got a property, got a reason. I solved the equations by using the addition, subtraction, multiplication, division properties of equality. Now there's the addition and subtraction properties of inequality. And there's also going to be multiplication and division. But like he's saying, they're different. With multiplication and division, if I multiply or divide by a negative, I will flip my symbol, but not when I subtract. And not when I get a negative answer. Okay? Just when what I do to the equation is to multiply or divide by a negative. So these first problems here, I'm just adding and subtracting, and so we don't have to do any flipping of symbols. Okay? Alright, so let's look at this problem right here. We're going to use our pen in just a few minutes, or our colored pencil, but for right now we're just going to solve a very simple inequality. M minus 8 is greater than or equal to 2. I'm trying to get my variable by itself, so I add 8 to both sides. So M is greater than or equal to 10. That is my solution. Alright, also I want to symbolize or show this solution on a graph. On a graph, I'd like to see 3 numbers on your graph. On these kind of graphs, the number in the middle, 1 less than, 1 greater than. Now, referring back to what we talked about earlier, if I've got greater than or equal to, then on my graph, I'm going to use a colored in circle. I'm trying to find a good color here. A colored in circle. And then notice that this symbol is pointing you. Pointing. I know the mouth is open toward the bigger number, but these solutions are greater than or equal to 10. So it's pointing you color to the right with your pen or colored pencil on this graph. There's greater than or equal to. Now that's one way we're going to represent our answers. Another way that we need to understand is called set builder notation. Now we know how to draw the set symbol. We've gone over that all year. But what we're saying here is, what are the solutions? This is part of your answer. Not just this, not just the graph, but set builder, and then we're going to talk about interval notation as well. So I want you to know how to do all of these, so write them all down. But this is just the set of m's. You write your variable here. And most books will either do a colon here or a straight line. I guess my habit is to do the colon because that's what I got used to doing first. But this colon reads mathematically such that. In this way, like this. Alright, so the set of m such that m is greater than or equal to 10. So for right now, with these very simple inequalities, you just take what was here and put it right there. That's all you do. Okay, now interval notation looks different. But you'll get used to it. Alright, interval notation is going to look like an ordered pair. If I have a colored in circle at a number, that is the only time I will use a bracket. The only time we'll use a bracket is if we have a colored in circle, because we had an or equal to symbol to begin with. Okay? Or equal to includes the 10, and so does the bracket. So looking at my graph, these solutions start at 10, and look guys, where do they go? To where? It's infinite. What do you call it when it goes to infinite? Infinity. Buzz Lightyear, to infinity and beyond, right? So this is going from 10 to, and here's the symbol for infinity. It looks like a little skinny sideways 8. Now infinity is not closed, It's wide open because it goes forever. So I use parentheses there. Now sometimes you'll see a little necklace with the infinity symbol for you guys to give your girlfriend. You can get her an infinity. I will love you forever, Dalton. You can purchase one of those for Christmas. I'll love you forever. If you're not into forever, don't get infinity. Just get a heart, man. Don't go infinity. But infinity tells us that this arrow is pointing forever. In other words, 10 is a solution, 10.0001, 10.5, 10.9, 11, every fraction and decimal in between here, every solution all the way to positive infinity. Now, if there's positive infinity this way, what's that way? Negative infinity, that's right, negative infinity. Alright, this said, somebody said this was confusing. This is saying at 10 it's closed. It's closed at 10, it includes 10, it starts at 10. I'm reading this from left to right, just like I'm reading this. From 10 to positive infinity. From 10 to positive infinity. Includes 10, includes 10. Now when you get used to it, this is so much easier than this. It's less writing. But understanding it's a different thing. Yes, sir?
Can we go back a page so I can finish writing?
No, not right now. Alright, let's look at this one. Alright, again, you know, this is like a one-step equation. And so I would subtract 7. Get my answer. Bring down my inequality symbol, okay? Not an equal sign. Move the whole thing, I think. Alright, so I'm going to do my 3 points on the graph. And now negative numbers go the opposite direction. Did you know that? So when I'm drawing my numbers on my negative side of the number line, instead of 17, 18, 19, it goes 17, 18, 19. Because they get smaller and smaller and smaller as you go this way. I mean, would you rather owe $17 or $19, right? These numbers are actually greater on the right, and that's true all over the number line. Alright, so on my graph, would I use an open or a closed circle? Well, I look right here, and it's right. And so at 18, I will use an open circle. And that means negative 18 is a starting place, but it does not include negative 18. And these solutions are less than. It's pointing you in the direction of color. Less than goes this way. Alright, do your graph. Alright, now let's do set builder and interval. Showing you both of these because by the time you're taking the ACT, you know, I think they'll probably have some interval notation on there. They may have some set builder, maybe mixed in. When you're in pre-cal, you'll definitely be using interval notation. So this is just to expose you to everything. Alright, so this is the set of C's. Why did I pick C? Because that's the variable over here. The set of C's such that C is less than negative 18. Alright, let's do this. Alright, so reading from left to right, starting on the left, where does this start? What is this? It starts at negative infinity. And negative infinity is open. And so is negative 18, because it's not included. So I do parentheses on both of those. The only time we use a bracket is when we're talking about a number, not ever infinity, but a number that's colored in. That's the only time we use that. Alright, questions? Okay? Now I'm going to switch over and start talking about multiplication and division. Alright, now we talked about properties before. Here are the properties for multiplication and division, just like you said a while ago. When I'm multiplying both sides by C over here, as long as C is positive, less than stays less than, even when I multiply or divide. Greater than stays greater than, even when I multiply or divide. However, when what I'm multiplying and dividing by becomes negative, the symbols flip. Less than becomes greater than becomes less than. When I multiply or divide by a negative, that's what those properties say. Okay? So we could write this in words. When we multiply or divide by a negative, the symbol flips. That's what it's saying right here. Okay, let y'all copy that down. Alright, let's look at these. These are very, very simple. One step. If this was an equation, we would notice to divide both sides by 3. We're going to do the same thing since it's a greater than symbol. We'll divide both sides by 3, and x is greater than 2. We're going to graph. Put our 3 numbers on there. Okay, at 2, will I have an open circle or a closed circle? Open. Alright, greater than is pointing you in the direction of color. The numbers get greater than to the right. We'll use our colored pencil there and graph. Right, see if you can do set builder and interval notation. See if you can do those, and then we'll do them together. Okay, so this would be the set of x's such that x is greater than 2. And interval notation, reading from left to right, it's open at 2 and then it goes to positive infinity. How did you do on set builder and interval notation? We're good? Awesome. Very good. Alright, now this thing right here, here's my comment on this one. We read math from left to right, and we really need that variable to be on the left when we finish, and if not, sometimes we just like graph it totally wrong and misunderstand the sign. And so I've got a multiplied 2 in the way. I divide both sides by 2, and my answer looks like this. Well, I need my variable on the left, and I notice that the mouth here, what I would call a mouth, is open toward y, and so I actually turn it around. So instead of coloring to the left, I'm really going to be coloring to the right. And so it'd be colored or open? Yeah, at 8. And then greater than, I'm really going to color this way. And so then set builder would be the set of y's such that y is greater than or equal to 8. Alright, will I use a bracket or parentheses on the 8? Y'all are not clear? That's hard. That's always hard for everybody to remember. Right. The only time you use a bracket is when you've got a colored in number, so this is actually going to be a bracket. So it starts at 8 and it goes to infinity, which is always open, so we use parentheses there. What do you think about that? Let's look at these two. The only reason I like to work this problem here, this first one, is number one, the variable is on the wrong side. And number 2, I got a negative answer. When do I flip that inequality symbol? When I get a negative answer? When I do. What do I do? Multiply or divide by negative. And I divided by a positive 5. But my variable here needs to be on the left. The point is pointing toward X. It still continues to be. There you go. Alright, graph, do set builder and interval. Graph, do set builder and interval notation. Remember the numbers go this way. 4, 5, 6. Go the opposite way of positive numbers. Always have someone get that confused. Hope it's not you, okay? 4, 5, 6 when it's negative. The opposite way. Alright, is this going to be open or closed at 5? Negative 5. Yes. And then less than means I'm going this way on my graph, because numbers get smaller that way. And then set builder is like this. And then how does this read from left to right? Yes.
How can you put it like that on the other side instead of just right here for parentheses?
Oh, I have no idea. Thank you. I was thinking about something else, apparently. Sorry.
Or wait, no, because it's closed on.
See, y'all are learning, but I'm going nuts. All right, how about that? So parentheses and bracket. Phew. Maybe I need a nap. Homecoming's just gotten to me. Y'all too. I can tell by looking at you. Y'all too. We could go to sleep, couldn't we? Alright, now let's look at this one. We see fractions sometimes. We think, oh no, can't do that. But this is a divided 3, and to undo anything divided, I multiply. So A is greater than or equal to 12. I'd multiplied by a positive number, so I didn't flip the symbol. Alright, graph, do set builder and interval. See if you can do them. Where's practicing? See if you can do them. Graphing, set builder, and interval. So my positive numbers going this way. Open or closed? Closed. Greater than going this way. Alright, so this would be the set of A's such that A is greater than or equal to 12. And reading from left to right, I have a bracket at 12 and go to positive infinity, which is open. Agreed? Alright, any questions? What do y'all think about this? Is it hard? Real hard?
There's just a lot of stuff.
There's a lot of steps. That's it. That's it. Now, the solving part of it is no different from what we've been doing, but the graphing, the set builder, and intervals on you.
Well, we have to do both of them.
Yes, all 3 of them. Graph, set builder, and interval.
It's all 30 steps.
Right. And part of it, you're getting the color. How can you beat that?
So does it matter does it matter if you put your infinity sign first?
It matters a great deal because you have to go from left to right, okay? Alright, now let's look at these. Why are you going to be flipping a sign? Multiplying and dividing by negative. You're exactly right. Good job. Good job. Alright, so let's look at this one. This is understood to be a what? Yeah, negative 1. And so I will divide both sides by negative 1. And then what's going to happen here is it was greater than, and because I divided by a negative, it becomes less than. That's the whole new trick right there. That was it. Hope you were watching. Because I divided by a negative, the greater than became less than. That was it. It's not difficult. It's just when you're solving the problem and you come to a place where you multiply or divide by a negative, it has to occur to you. You know, that I need to flip this. Alright, graph, do set builder, and interval. And remember, the negatives go the other direction. This one is open at -9. It's less than, so it goes this way. This will be the set of x's such that x is less than -9. Now let's read. This is what you were asking a minute ago, Zach. Does it matter where I start with? Looking on the number line, where does it go from the left? Coming from the left, where do I start?
You're gonna start with your number this way,
I'm
no,
gonna-
it'd be on the right. Your number
So,
would be
so
on
what
the
would this represent?
right. The infinity sign.
So from -infinity up to -9, and they're both wide open.
I can't draw good infinity signs.
Yeah, you can. Turn your paper sideways and make a skinny 8.
Okay.
You can turn that paper, it'll work just fine, till you get used to it anyway.
Mama put a fish.
Yeah.
Wait, so how come you didn't put a bracket on that one?
Why did I not use a bracket, guys?
Because the start has that.
I didn't color in my number, right? I didn't put a colored in dot on my numbers. Why?
Oh.
Alright, I want you to take this problem and do the whole thing. Solve it, graph it, do set builder and interval notation. Do the whole thing. Now you're going to be dividing by a negative, so do not forget what's going on when you divide by a negative. Yes? Need some help? Okay. Alright, so we're going to divide by -2, and we're realizing, hey, we're dividing by a negative, so that's going to flip the symbol. Think about your number line. Is your number line going the right way? And then we've got an open circle here, and greater than's going to the right. So that will be the set of m's such that m is greater than -5. And so looking here, where does this start? Where does it start? At -5, and that's open. And where does it go? To infinity.
Okay, so why is that one going that way and the other one's going this way?
Look, this arrow's going that way. This arrow's going that way. Yeah, look here, less than. Telling you to go this way, so it starts on the left at -infinity. This one starts at the -5 and goes to infinity. It's all about the graph. It's all about looking at the graph, and that's where you get these two things. We'll pick up there on Monday.